And good morning, everybody. Thanks for joining us today for this exclusive PhaseOne and Copters presentation. How do I find myself here today? Well, I'm James. I am the Business Development Manager at Copters, and I primarily work with survey and construction businesses, helping them introduce drones into their companies. I studied surveying and mapping science at Newcastle University some years ago now. This was first where I came into contact with drones, essentially used it in a coastal monitoring environment, comparing it with traditional techniques and comparing it with drones, essentially. And even back then, drones were a really great way of collecting highly accurate data efficiently and effectively for survey applications. So I left university. I worked in the offshore industry for 4 years as a dimensional control surveyor, and this was where drones were just entering the market as a means of collecting inspection data to make informed decisions about how to move forward with remediation works and saving time and money and reducing people, putting people in these hazardous environments. So I joined Copters, as mentioned, in 2017 and worked primarily with survey and infrastructure companies introducing drone programs. If you like, next one slide, Jimmy. So these are just some of our partners at Copters. Obviously, LiDAR USA. We do LiDAR units for anything from M210s, M600s, and anything essentially where the drone can pick up that type of payload, then we can integrate it on there as well. We're global mapper resellers for integrating any LiDAR software, LiDAR collected data, and also we're a Pix4D reseller in the UK as well as a trainer. PhaseOne, obviously, that's why you guys are all here today to understand and fully learn about the ins and outs of the iXM camera range, and we've got two experts in the field here to go through that with yourselves. Resellers of the Wingcher, the VTOL system in the UK, fantastic fixed wing. DJI, difficult company to escape nowadays with 80% market share. But do produce some really great drones to get people involved in the UAV market. And we've got obviously AceCore and Parrot, as well as Flyability, the Elios as well. So that's what we do at Copters. We're an all under one roof solution and can provide everything from training, drones, software, help and support along the way. So without further ado, I'd like to hand you over to James Wardlow, who is the sales representative for PhaseOne with industry experience, as well as Chief Scientist Yuri, who will also go through the calibration side of it. So hand it over to you now, James, and hope everybody enjoys it.
Okay, good morning, everyone. Thank you for joining us and tuning into this webinar presentation. I'd just like to introduce myself. I'm James Wardlow, so I'm the System Sales Manager for PhaseOne in the EMEA region. So primarily I'm covering the UK, South Africa, Australia, Estonia, Latvia, as well as global reach for the fully integrated airborne systems. I'm joined by my colleague Yuri Reisman. Yuri is the Chief Scientist for PhaseOne, so responsible for the development of the imaging technology, the processing, calibrations, and quality assurance for the camera side. So just to fill you in on the topics presented here today. So we'll start off with a brief presentation on who PhaseOne is. Some of you may already know PhaseOne as a company. Some of you may not. So we'll start with just a brief presentation of the company. Then we'll go on to presenting more in depth the specs for the iXM camera, which is the PhaseOne medium format UAV camera. And then we'll look at applications such as inspection, the benefits of using a PhaseOne camera for inspection, some case studies that support those arguments, and then we'll also do the same thing for the high accuracy mapping side. And then following up, Yuri will finish off by explaining some accuracy assessments, the calibration procedures, and just explaining the importance of using a fully metric camera for high accuracy mapping application. So PhaseOne as a company, so we were founded in 1993. So we are from the professional photography market. So medium format cameras supplied for marketing, media, advertising, modeling, landscape photographers. Over the years, we found that a lot of our customers were using the cameras in an airborne application. So in 2012, we decided to found PhaseOne Industrial. So over the years, PhaseOne Industrial has spread now to aerial photography and ground photography. So the aerial photography is covering both manned application and unmanned application. And in our ground unit, we're doing machine vision, digitization of cultural heritage, and also ground inspection. As well as the hardware side, we also have the software business. So we have the Capture One software, which is a software similar to Adobe Photoshop and its tools for doing image corrections. So in the industrial application, you can use that software to do corrections to your exposures, corrections to your high dynamic range, your levels. And then we also have a further range of software that supports both the unmanned side and the manned aviation side. So PhaseOne is the market leader in medium format imaging, and we are a trusted brand with more than 100,000 satisfied customers. So the global coverage, so as mentioned, our headquarters is in Copenhagen, Denmark, and that's where our main research and development center is. We also have 2 further R&D centers in both Israel and Japan. So Israel is focused more on the industrial side of the research and development. So taking the digital components from our main headquarters in Denmark and then building them into the industrial units that we all know for the manned aviation and unmanned. On top of the research and development, we also have various global sales and support centers. So for EMEA, our sales and support is based in Cologne in Germany. We also have sales and support center in Denver, Colorado. And then we also, for our Southeast Asia and Asia Pacific region, we have sales and support in Hong Kong. On top of our direct coverage, we also are supported on a global coverage with more than 50 plus distribution service partners, of which our colleagues here in the UK are copters. So typical applications that our customers are using our cameras for. So 3D cities is a big topic at the moment. So 3D city mapping, oblique systems, smart cities. We also provide cameras and fully integrated systems for 2D airborne mapping applications. We've got various integration partners worldwide that build our cameras into other bespoke systems as well. Our cameras are used for engineering applications, asset management. We offer 4-band RGB and near-infrared camera kit for forestry, agriculture, research applications, UAVs for infrastructure planning, power line monitoring, and also open pit mining. So looking now at the iXM series in more detail. So the iXM comes in two main form factors. So we have the iXM, which is a medium format crop sensor, which is our typical UAV camera. And then we also have the iXM-RS, which is a full frame medium format camera, slightly heavier and slightly larger than the UAV camera. So it's not usually seen on a UAV application. Looking at the full range of cameras, so the iXM comes in 2 main forms, 50 megapixel and 100 megapixel. So the 50 megapixel is supported in an RGB CMOS sensor. The 100 megapixel can be supplied in a 100 megapixel RGB anachromatic sensor. And then we also have for the full frames, both RGB and achromatic options available. And then we have our 190 megapixel and 280 megapixel multi-head camera systems, which are for the larger aerial airborne systems. So our cameras are now using the very latest Sony backside illuminated sensor. So the reason for this is that when you start trying to cram more pixels onto a sensor chip, what you have to do is physically shrink the pixel size. So typically by shrinking the pixel size, what you're actually doing is reducing its ability to absorb the light that the lens is receiving. So what this will then do is give you lower dynamic range, and it will really affect your ability to operate. So Sony perfected the technology of replacing the architecture of the sensor, taking that metal wiring that takes the signal from the pixel to the analog digital converter. They took it from the front of the sensor and placed it on the back of the sensor, which now means that more light is available to get to the actual individual pixels. So from this, you still support a wide dynamic range, which improves your light sensitivity, which therefore increases your flying hours per day, which effectively means more flights achievable per year, and also maintains the object resolution in low light conditions. So the iXM is PhaseOne's first camera that comes with full IP53 weather protection. So this protects it from rain droplets, dust, and various other particulates that are covered under IP5 This is ideally this is a requirement for a UAV application because you're outside with a platform that's unprotected from the elements. So it's really important to have the IP53 on this unit so that your investment is protected from the likelihood of being caught out in the rain or other weather conditions, if, for example, flying in dusty conditions. The cameras are also classed under FCC Class A, CE, and ROHS, so fully classed for airborne and industrial application. It's a compact and robust design, so measuring 90mm by 90 by 68 for the camera body, and the camera body itself without a lens is weighing about 630 grams. The way that we've managed to get the medium format camera down into such a weight category is purely from using the crop sensor, so we can physically put a smaller sensor into a medium format body. We also removed quite a few features from our previous generation of cameras, including LCD displays and various buttons located on the back of the camera, so we could actually make the camera much more compact. And it also gives the ability on the back of the camera, therefore, then to mount external devices such as a cooling device, heating device, or an external GNSS IMU device. So the connectivity for the iXM-RS and iXM series camera. So internally, the storage can be collected on a Sony XQD card. So currently supportable up to 256 gigabytes. We are currently looking at options to extend to the very latest compact flash cards, but that's still work in progress. External connectivity from the camera. You can connect to external devices via high-speed USB-C, and there is also built into the camera 10G Ethernet via SFP Plus module, which can support copper or fiber transmission of data. Not quite as oftenly seen on UAV applications, but of course, as UAVs are getting bigger and gaining bigger payloads, then more advanced integrations with cameras are coming forwards. But all of this architecture can support effectively with the 100 megapixel camera, 3 frames per second, and with the 50 megapixel camera, 2 frames per second. So just a quick slide on explaining how the camera sizes differ in terms of weight and size. So on the left, we have the 100 megapixel MF camera, which is our commercial equivalent. Then in the middle, we have the iXM-RS, which is the 100 and 150 megapixel full frame, and the blue is highlighted for the iXM UAV camera. So you can really see there how we've really managed to streamline the design to really put all of that medium format performance into a small compact unit that is usable on UAVs. So typical PhaseOne application. So the iXM on typical UAVs. So pictured on the left, we have the good old trusty DJI M600. It's a very good workhorse. With the pricing point of the M600, it opens up the door for users to be able to use our camera in a cost-effective way. We also have the German drones, an integration that is fully complete, which is a heavy lift VTOL platform. The full range of Ace Core drones carries a full PhaseOne integration, Aerialtronic Zenith, and then also the iXM is also typically built into small multi-camera arrays for manned aircraft application. We then have the iXM-RS, which are generally built into manned aircraft platforms. So we have our own fully integrated PhaseOne aerial system, which is a 190 or 280 megapixel large format camera system. And then we have various integration partners that build those cameras into different bespoke system packages, like IGI in Germany, making 8-camera PhaseOne solution for oblique and large area coverage. And then we also have a full range of LiDAR manufacturers, Regal, Optec, that also build the PhaseOne cameras into their LiDAR units. So in typical applications for each camera, so iXM is usually road and bridge inspection, pipeline inspection, rail track inspection, wind turbine, power line, and typical photogrammetry mapping and GIS applications. And then the larger cameras built into the manned aircraft platforms are generally for photogrammetry and mapping, agriculture, oblique, which includes a 3D city modeling, and then in combination with other sensors, imagery for LiDAR, and also some helicopter imagery for inspection. So looking at the individual specifications, so the 100 megapixel, it's actually 102 megapixel, has a cross-track resolution of 11,664 pixels and a forward-track resolution of 8,750, very high dynamic range of 83 dB. Pixel size is 3.76 micron for the 100 megapixel and 5.3 micron for the 50. Just for your note, the 50 megapixel is using the previous generation CMOS, so that's why it has a slightly higher dynamic range of 84 dB, but the capture rate is significantly higher on the 100, so 3 frames per second sustained capture rate from the 100 megapixel. So in the range of lenses for the iXM, so the initial range is the RSM lens. So as mentioned, the iXM camera has a cropped sensor built into the unit. So to support that, we had to physically develop a whole brand new range of lenses with a lens architecture that fits with that cropped sensor. So they come in 2 main variants. So we have the prime lenses, which come in the 35mm and 8mm lenses. They're focused to infinity, so absolutely perfect for mapping application. The 35mm is a super wide field of view, which is 35mm equivalent, I think, of 27 millimeters. And this gives you a 64-degree field of view, so very wide coverage. And because the lens is tailor-made for the sensor, you've got very good distortion-free characteristics across the whole range of the lens. So even at wide open aperture with the 35mm, at the edges of the image, you'll still have full clarity, no keystoning effect, so an exceptionally good lens for mapping application. We also have the inspection lenses, so 80mm, 150 and 300mm AF lens, which is autofocus. These lenses are essentially inspection lenses, so you can position your camera and drone to within a certain distance of the feature that you want to inspect, and basically you can get to within 3 meters of that object with the 80mm, or the 150mm and the 300 from 10 meters to infinity. The lens will focus to. So essentially, you can support sub-millimeter resolutions with those lenses for your inspection application. We'll go into a little bit more detail in that in coming slides. So the lenses themselves are designed as high resolution 120 LP per millimeter over 55mm image circle, which is very important as it really allows the lens technology to support the resolution of the sensor. What you will find is generally with commercial cameras, the resolution is not supported typically by the lens, so you won't get such high LP values for commercial lenses, and that you can really see in the NTF values and other graphs. So the lenses for this is built specifically for an aerial application, with the resolution being supported right out to the edges of the image. They are a flat field design, so again that leads to low distortion values, and as mentioned previously, the focusing range allows us to support from capture distances of 3 meters to infinity. All the lenses have high spectral response in both visible and near infrared range, and they're all firmly and pressure stabilized for wide operation conditions. They all come with the PhaseOne RS shutter. So the RS shutter is an in-house developed leaf technology shutter. It contains a direct drive electromagnetic motor, which has minimum moving parts, therefore leads to very low mechanical wear. There's also a PWM control in there, which gives accurate blade acceleration control. So this really allows us, along with that direct drive and the fact that the lens is normally an open shutter, which means that the fast acceleration is only one direction, that we can really increase the longevity of this lens. So guaranteed, the lens comes with 500,000 activations before there's any potential chance of failure or loss of accuracy in the exposure time. But what we've actually found in the market is that we have customers that have run these lenses way past 1 million activations with no issues. So very reliable technology, and been on the market now in PhaseOne cameras for the last 3 years. So with the CMOS sensors shifting from CCD sensors used to have a form of motion compensation built onto the sensor, which was called time delay integration. When we moved to CMOS, CMOS no longer supported that technology. But what the technology of the new sensors actually allows is when running with a higher shutter speed, so shutters up to 1/2500 of a second, and that higher dynamic range that the medium format sensor provides, we can actually implement a blur control, which we've coined blur control technique, which is now a published and recognized blur control method. So as you can see in the examples, it allows you to run higher ISO values, which generally would introduce noise into the imagery. But this actually allows you to run a faster shutter speed with a higher ISO setting and still get exceptionally clear imagery, even in the darkest shadowy areas. So yeah, blur control technique is a proven method of forward motion compensation. And then just two further examples just to support that. So the example on the left showing the private jet. So we were actually flying in a Cessna 206 aircraft from the bottom to the top of the image. And this private jet was taking off from a regional airport. So we had approximately a closing speed of 230, 240 knots. But as you can see, looking at the image, there's absolutely no blur whatsoever on the aircraft. And this is because of the blur control technique. And then the same can be said about the helicopter on the image on the right, which is actually in full flight. So as you can see, the ability to capture those blades, they almost look as though they're stationary, and no visible blurring can be seen on those lenses. As well as the RSM lenses, the iXM UAV camera can actually also support our full range of RS lenses, which are for the full frame camera. So we have an adapter that allows us to install anything from our 23mm up to the 180mm lens. So these lenses, as mentioned, are built for the full frame sensor, but actually when using a full frame sensor, a full frame lens on a crop sensor, means that sensor is not using the full field of view of the lens. So actually what you're actually using is the best part of the lens. So again, using the full frame lenses on the iXM camera leads to exceptional image quality, and it also extends the number of lens options that you need to use if you have to say push up the GSD from a higher altitude. Then the lens options are there to support this requirement. The only downside is because you have to include a slightly heavier adapter, it does raise the weight just a tiny little bit. So as well as the hardware, we have the full software side. So the software side allows full control of the camera. Because the shutter is always in the open position and only accelerating closed during the image capture, it allows us to actually provide through HDMI live video preview. So anything that the camera is looking at, the operator can see. You're also, as highlighted by number 2, receiving a preview of your previous image. And on top of the preview, you're also getting full histogram and exposure feedback. So you can really fine tune your capture specs to make sure that you're really getting the best image possible to support your customers and support your application. And also through this, you can fully control the focusing method of the camera, so that you can ensure full clarity of the image, full perfect exposure. So really delivering the best product possible to your customers. We also, because the camera is a fully metric camera, it can be fully calibrated and provided with a metric camera calibration report, which provides the full distortion relationship between the lens and the sensor. As well as this, we can provide full radiometric calibration reports, and these reports are stable. And as you'll see when Yuri makes his presentation regarding the calibrations and the accuracies and the assessments, the metric calibration is stable and is very accurate. So with this, essentially, you're taking out that step in your processing where you've got to continually ask the software to do a self-calibration of your data set. So when you have a PhaseOne camera and it's fully calibrated, you're taking one step out of your processing already, because you just import those values already into the software, and it already knows how to take care of that during the bundle adjustment. So looking at inspection in a little bit more detail, so the example on the screen just showing a very typical application for our camera is power line inspection. So what we're saying is the camera is effectively able to deliver the crucial details. So what you can actually achieve with a PhaseOne camera is to get sub-millimeter resolutions from 20, 30 meters away from your target. Whereas typically when using a conventional UAV camera, you're having to fly much closer to your target to support the same resolutions. You're having to take more photos. And the ability to actually fly further away from objects, especially in the example, a power line, you're running much safer operation because you have less chance of magnetic interference, much less opportunity for GPS occlusions. The aircraft itself is not being affected by turbulence that could be coming through from wind coming through the object and being disturbed or disturbing the airflow. So that ability to stand further away not only increases your productivity, but you're also increasing your safety. So you're protecting your investment. And in discussions with one of our UK customers, the actual cost of running into a power line with a drone and leaving the drone hang on top of the power line in such a case, the actual cost of doing that and having the power line shut down and the UAV recovered is a very costly exercise. And trust me, it makes the camera look extremely cheap. Another inspection application, which is supported by a case study by a customer of ours in the UK, Plowman Craven. They're using the PhaseOne camera to basically measure the track geometry, measure the track condition, and collect various different measurement data. So they're flying approximately 25 to 30 meters over the railway line, and this has given them the ability to create a point cloud of around about 1 millimeter in resolution. So this is actually for the end customer shortening of their program times, which is therefore giving them significant savings, cost savings. And at the end of the presentation, I've actually got a small video that I'll play, which shows some of the just a quick video fly through of the point cloud data, just so you can see the kind of data is coming from this. Another example for inspection, and then Nick will go into a little bit of detail about camera comparisons and some of the various typical UAV cameras used. So this was actually flown with a partner of ours in the US, a company called PhaseOne Aerial Surveys. And this was a bridge inspection from the Tacony Palmyra Bridge in Philadelphia, USA. So for the test, they wanted to really see what was the difference when flying a DJI Zenmuse X5, the Sony A7R, just the straight 36 megapixel, and the PhaseOne iXM-100. So there were different flight parameters carried out during this test. There's more details of this on our website. It's supported with a separate webinar and a case study as well. So I won't go into full detail. But just in the examples that you can see in front, basically these photos were taken from a 30-foot distance. So with the Zenmuse, it's giving a GSD of 2.3 millimeters. With the Sony, it's giving a resolution of 0.9 millimeters. And then from that 30-foot distance with the PhaseOne, we're getting just under half of a millimeter resolution. So then when we start looking at that in 100% pixel level, you can really start to see that that image coming out and the details that you can extract from that image. And again, just in a slightly larger format. So really from that distance, you can really start to really inspect your subject. So the other part of the test was also to actually do some 3D modeling of that bridge, and this is where the comparisons come in. So effectively, we flew the same subject 3 times with the X5S, the Sony Alpha, and the PhaseOne, and then we really made a comparison of just how much time was saved on this. So highlighted in green are the key values from the PhaseOne iXM, or the key values in general. Anything highlighted in yellow is where it starts getting a little bit sketchy, and highlighted in red is just outright dangerous. So when we look at, for example, supporting a GSD of 0.43 millimeters with the X5S, it's not even practical. You have to fly 1.3 meters away from the target, which is just not practical in any terms. The Sony Alpha is a little bit more practical, 4.4 meters, but the PhaseOne, you're covering that from 9.1 meters to get a resolution of 0.5 millimeter. On top of that, when we look at the actual number of images that it would take to capture, with the PhaseOne to support that bridge at that section of bridge at 0.5 millimeter resolution, it would require a total number of images of 2,787 compared to the Sony of 3,200 and the X5S at 5,100. And when this actually turns into practical flight times, it's 42 minutes to complete that with the PhaseOne, 88 minutes to complete that with the Sony Alpha, or 300 minutes to complete that with the X5S. So you can really then start looking just from that one job how much you can actually save by using the PhaseOne to collect that data. As well as the actual efficiency side again, I'll mention the safety side. So you're able to capture higher resolutions from much further distance from the object. So again, you're saving yourself from GPS occlusions, turbulence induced from wind, navigating around that structure. And then on top of that as well, the other key benefit of using a medium format camera is the fact that the medium format sensor with its higher dynamic range gives you the key benefit that when you're looking at items under the bridge that are in shadowy areas, with that high dynamic range, you can really pick out the detail in the shadows without introducing any issues in the imagery to the saturation or to the sharpness of the edges. Whereas with the Sony Alpha and the X5S especially, as soon as you started trying to extract that data, you really started losing clarity in the edges, so it really started affecting the quality of the model. So all of the combinations of the efficiency, your safety, and the sensor specifications to support the high dynamic range really do go forwards in bringing forward your productivity and profitability. And then again, just the key points. So higher resolution possible, so better than 1 millimeter, more safety distance, larger coverage, less images, shorter flight time, and that equals higher efficiency and more safety. Now let's look at the iXM in a mapping application. So this was a case study flown with one of the universities in Germany of the Zechshollen facility. So again, this was flown basically with the PhaseOne iXM-100, and we also have the DJI Phantom 4 Pro and the DJI Zenmuse X5S as comparisons. So what we can see from this example imagery is all cameras flown at 1.36 centimeter resolution, or the altitude support 1.36 centimeter GSD. And what we can actually take from that is when you physically look at the differences between all of the images at 100% pixel, you have on the left the Phantom 4, in the middle we have the X5S, and then on the right we have the iXM-100. So what you can actually physically see is, even though it's your perception that you're achieving 1.36 centimeter resolution, the combination of the sensor and the lens is actually not fully giving you that resolution that you would expect. Whereas with the PhaseOne, you can actually fully see individual details in the grass. You can see a little bit more clearly the definitions in the circle patterns, and also there's a lot more contrast between the colours on the colour board. So then just another quick example of that. So again, the DJI Phantom 4 and the PhaseOne iXM over an area with some urban features. So when we look at that at 100% resolution at 1.36 centimeters, you can really start to see massive differences in the data quality. So on the left, we have the Phantom 4, so you can't make out the guttering. The ground, the stones, they don't look as crisp. Whereas if we look at the image on the right for the PhaseOne, we have the full image quality, image clarity. You can make out the item definitions, so much better image resolution. So we look at how long it actually took and the efficiency to capture this area, which was a project size of 500 meters by 215, all flown at 1.36 centimeters. So we look at the number of flight lines required to capture it, and basically with the PhaseOne, we only had to fly 4 lines when compared to the Phantom 4 and the X5S. We had to fly 8. The Sony Alpha was slightly in between, somewhere 6 lines. And then we start looking at the actual total flight times. To cover this area at max flight speed with motion blur of less than 1 pixel measured in the image, the total flight time with the X5S and the Phantom 4 would be 41 minutes to complete that entire area. Whereas with the PhaseOne, we did that area in 2.9 minutes. So massively more efficient in data collection. Then we'll look at some theoretical numbers. So we'll look at coverage of what the various typical UAV cameras could do in a 15-minute flight time. So we ran this exercise in support with Airtronics in the Netherlands. So all numbers are based off of their flight parameters. And what we can effectively see here is that in a 15-minute flight time with the PhaseOne iXM-100, you can cover an area of just over half a square kilometre in 15 minutes. Whereas with the Sony Alpha 7R2 and 7R3, you're looking at somewhere between a quarter of a square kilometre and half a square kilometre, just at 0.34 of a square kilometre in 15 minutes. So again, massive improvements to your productivity with the PhaseOne. And then we'll look at that. Actually, we'll look at this next graph, and this is actually turning those numbers into a productivity based on a given number of hours. So the bottom blue line is saying if you flew 50 hours with each camera, how many square kilometers would you typically cover at 80% forward overlap, 60% side overlap? The orange line is 100 hours. The silver line is 200 hours. The yellow line 300, and the blue line is 400 hours. I mean, when we think about 400 hours a year, that's only eight hours a week of UAV data collection. So not massively out of the realms of possibility. But when we actually look at this in comparison, even against the latest Sony A7R4, if you flew 400 hours a year with the PhaseOne, you're covering just over 1,100 square kilometers, whereas with the Sony Alpha A7R4, you would cover under 800 square kilometers. So a difference of around about 300 square kilometers. So if you actually look at how many hours you would have to fly with the Sony A7R4 to support 300 square kilometers, so we would have to fly somewhere around about an extra 200 hours to cover the same area with the Sony A7R. So in terms of the message here is, with the PhaseOne, you can achieve a larger area coverage with less images, shorter flight time, greater quality, and that all goes forwards to enabling a higher efficiency. And certainly in terms of the less images and with the metric calibration, when you start looking at that and feeding that into your post-processing software, because there's fewer images for the bundle adjustment to make the correction on, because the camera is also metrically calibrated, so there's less for the software package to also do. That's also going to increase your efficiency and your processing time. So higher efficiency in processing, higher efficiency in data collection. So this all leads to higher productivity when using the iXM. So that's from my side. So that's basically from me. I'd like to now hand over to Yuri, who will just go into some details regarding the accuracy analysis for the iXM-100 and the other PhaseOne cameras, and also just to discuss a little bit about the calibration principles, and the deployment. So over to you, Yuri.
Yes, I'm here.
Yep.
Okay. Hello, everybody. Okay, we'll talk about accuracy. And you know that we need accuracy for mapping and sometimes for inspection also. We will start from our test field that we have here in Israel. And actually, most of our cameras are flown over this test field, and we are testing every new series. Actually, when we creating it, we are testing on this test field. This test field, the size is about 2 and 1.2 kilometer. We have 45 ground control points that were measured by very accurate GPS, and the accuracy on planimetry is 0.8 centimeter, and accuracy on altimetry is 1.3 centimeter. On this test field, we use well-defined man-made features like you see here on the bottom of this slide. Next slide. James? Okay, thank you. The first camera that I will present here, it is the iXM-100 camera with focal length 35 millimeter. And this camera actually dedicated for UAV and drone applications. The flight was done not from UAV, the flight was done from aircraft, small aircraft. And the ground sample distance was 3.5 centimeter, flight altitude 1,000 feet, side overlap 56, forward overlap 80%, and the number of flight line strips was 10, and in total number of images 215. Next slide. Okay, here you can see the results. Every camera, every photogrammetric camera, the camera is dedicated for photogrammetry and mapping. We can provide a calibration certificate for these cameras. And here you can see from the left side, it is original distortion of the lens. And from the right side, you see actually distortion residuals after we apply these calibration parameters to the image, and we are getting actually undistorted image. You can see that these residuals are well down than 1 pixel. This is 1 pixel from the right, and this is red arrows. It is distortion residuals that we provide after applying all calibration parameters. James, next slide, please. Okay, here you can see all calibration parameters that we calculate for our cameras. You see actually K1, K4, it is radial distortion, focal length, optical center of the image. P1, P2, it is tangential distortion of the lens, and B1, B2, it is differences in focal length according to different axes of the image. Okay, next slide, please. Here you can see accuracies that we reached with this camera, iXM-100, and ground sample distance 3.5 centimeter in this flight. We used only, from the left, we used only 7 ground control points, and from the right, we used 9 ground control points. And accordingly, from the left, we made the accuracy estimation on 37 checkpoints that did not participate in the adjustment, and from the right, 35 checkpoints. In both cases, you can see that we, from the left, we got planimetric accuracy about 4.7 centimeter and 4.4 centimeter on height, and from the right, it is planimetric accuracy is the same, and altimetric accuracy a little bit better. So we have here more ground control points, and altimetric accuracy we got a little bit better. In both cases, actually, the planimetric and altimetric accuracy with this low number of ground control points actually is around 1.1 pixel, 1.2 pixel, and with 9 ground control points, it is less than 1 pixel on altitude. Next slide, please. The next example, it is iXM-RS 100 camera with focal length 50 millimeter. This series of cameras are dedicated actually to airborne aerial survey, not for use with UAV, or maybe it is possible to use with large UAVs also, large UAV or large drones also. Here, ground sample distance was 5 centimeters on the ground, altitude was 1,780 feet. Forward overlap, side overlap, you see it. It was 8 south-north strips, flight lines, and 2 westies. So the flight was crisscross flight to ensure high accuracy of the mapping. Total number of images was 132. Next slide, please. Okay, laboratory calibration for this camera. You see more or less the same results that we presented with the previous camera. Generally, commonly we speak about, when we are speaking about distortion residuals, we speak about 0.2, 0.3 pixel for undistorted images. By the way, you can use original images when you process your data with some software. You can use original images and just to apply calibration parameters in the software you use for processing, or you can use our software iXCapture, and in iXCapture you can apply calibration parameters of the camera, and as output you will get so-called undistorted TIFF image, and further in processing in your software you will not need to apply calibration parameters also. Okay, next slide, please. Accuracy analysis for this camera. The same test field. From the left, we used only 5 points, 5 ground control points. In the middle, 9 ground control points. And from the right, 12 ground control points. And the accuracy on checkpoints, first from the left, 44 checkpoints. The accuracy was 3.8 centimeter and 5.4 centimeter on height. In the middle, 3.4 centimeter, 4.5 centimeter, and maximal accuracy 3.3 centimeter and 4.4 centimeter. So we can see that we are, in this case, we used actually crisscross strips, and our block has much higher accuracy. And on planimetric coordinates, on the XY coordinates, we always under 1 pixel, around 0.6, 0.7 pixel accuracy, and on height we around 1 pixel and under 1 pixel accuracy for this camera and for this flight. Okay, next slide. Thank you very much.
Great, thanks for that, Yuri and James. There is a couple of questions just to go through at the end.
Just one more thing, James. I'd just like to quickly play those 2 videos that just show some outputs. If I can remember how to do that. So this is just an output from one of the Plowman-Craven data sets. So it's just showing the results from the point cloud. So this is all 1mm point cloud.
Incredible.
And then just like to play the final video. And this was of a model that myself and James flew last year with the iXM-50. This was processed with Agisoft Metashape, and it was done in a traditional oblique flight path pattern. So this model is roughly at 1.5 to 2 centimeter resolution. Okay, so that's everything. So yeah, okay, over to you, James.
Questions at the bottom, which whilst we've got the experts here, it'll be great to go through them. So we've got a question from James at the bottom, who says, as it's a metric camera, do you need less control to scale and coordinate the photogrammetry model? Is the relative accuracy better due to improved optics? Are fewer ground control points required?
Would you like to answer that one, Yuri?
Yes, it's true. If you have a calibrated camera, you can use fewer control points and to get higher accuracy. Additional parameters you can take into account that you can, with PhaseOne cameras, specifically with PhaseOne cameras calibrated, and large format cameras, relatively large format for UAV and drone large format, I mean 50 megapixel, 100 megapixel, you can fly higher. You can fly higher. Your processing and aerosol reproductivity will be higher, and still you will get higher accuracy due to the fact that the camera is calibrated photogrammetrically. Okay, yes, it's true.
Excellent. And also, Derek's asking about price normalized against the productivity gains. I think in terms of these cameras, we know they're not going to be cheap. These are well engineered metric cameras. What do you say to people, James, who are looking at cost as an objection for them potentially investing in a camera like this?
Well, I mean, I'd certainly say that in terms of the price and their return on investment, what you're actually purchasing from PhaseOne is an industrial unit. So from that, you have the industrial service and support. So all of our products are serviced and supported for a minimum of 7 years. Because we're constantly developing those products, we also have excellent upgrade paths to newer models that get released in future. And this just in comparison to a commercial camera, you've just got your basic return on investment on a commercial unit. So I think a depreciation on a typical commercial camera is maximum 2 years. So whatever you invest in a commercial camera, it's basically a throwaway price, because when the new model comes out and you've already put a lot of activations on the shutter and the lens that you have with that commercial camera, generally there's no value left in that camera any further. So you're always going to be with a commercial camera following that same path of every couple of years purchasing a new camera, whereas with the PhaseOne you have the industrial build quality of the camera, so it's ruggedized. You've got the 500,000 activations guaranteed with the shutter technology, so you're supported there with that shutter. Whereas with commercial cameras, generally their lifespan of a shutter is no more than 100,000 activations, if you're very lucky, especially when you start applying them onto a UAV application where they're getting a lot of turbulence, a lot of buffering and bouncing around. Those shutter lives are massively reduced because they're purely not developed or designed for that kind of application. They're designed for someone to hold them in their hand and take photos of their family, and that therefore also leads on to the lens quality, because the lenses on commercial camera are really only developed to give you a really nice picture right in the center of the image. So when you get to the outside edges of the image, you get the distortion that is not usable, and that's why you have companies like SimActive with the correlated 3D software. They recommend minimum side overlaps of 40%. Whereas with the PhaseOne, because we have the distortion-free image right out to the edges, you can fly with much lower overlaps. I mean, still for true ortho production, you want to fly with higher overlaps anyway. But if it's just topo over farmland or agricultural land, you can easily fly with 25-30% side overlap without worrying about tide point generation in your overlaps.
And in terms of the after-sales support, James, if someone had a damaged camera for whatever, how quickly can you get them a replacement out?
Yeah, so basically we have a premium warranty scheme. So the premium warranty is basically an extra on top of our standard warranty. So with the premium warranty, what will happen is, if in case of a camera failure, we'll send an uptime unit out so that during your downtime with the camera, it's basically your downtime is minimized. With the standard warranty package, we guarantee to basically repair and ship cameras back out within a 2-week period. But with the premium warranty, as mentioned, we do supply that uptime unit during that maintenance period. And as well as the uptime unit, we also guarantee with the shutter that we will either replace that at the end of its 500,000 cycle, or at the end of the first year of the premium warranty package, we will also replace that shutter. So that at the beginning of year 2, you'll start year 2 with a brand new shutter with 500,000 activations, and that doesn't matter whether you've shot 10,000 activations or 499,000 activations. If you sign up to the premium warranty, you get the lens replacement at the end of year 1.
Excellent. So, sort of what you're saying when investing in something like a PhaseOne iXM, it's all about productivity, efficiency, and quality of that output at the end, which will shine through any software, and then in turn into the deliverable at the end. Outside your client. In terms of sort of the people you've dealt with in the past and the cameras you sold, what sort of feedback are you getting from these from your customer base?
So generally, the feedback is always extremely positive. We have, I can use one example in Germany. We have a customer AI survey. They're always very active on LinkedIn to promote the PhaseOne camera, say good things about the PhaseOne camera. They're always willing to talk to customers about the PhaseOne camera. So if you ever needed to get any further clarifications from someone who's really, I would say, in a position that there is no, what's the word? They're not being asked to say good things about the camera. They're really on the sideline. They're a good people to talk to. But in general, the feedback is that the companies that are always on the edge of whether they should purchase the camera or not, because of course it is a large initial investment, and they're always trying to decide whether or not with that investment they can find the work. The feedback coming back is that they always, once they've made that purchase, they always get the work coming straight afterwards. And companies are saying that from that they really they were silly not to make the investment sooner. And we've actually got a case study and webinar being released with that sentiment very shortly.
Excellent. Well, if there's no more questions,
I can see one question from Jules. Is this designed specifically for multi-rotocopters or can be used with fixed wing? Yeah, so it's with the cameras, they are designed for integration in mind. So we're very open with the camera. We also provide a full SDK package for the camera, which allows you to control not only the camera capture, but also some camera processing functions. So we have various different integrators worldwide that have developed different platforms. So we're on various different multi-rotors. So we have AceCore, Aerialtronics, DJI. For fixed wing, we have German drones as the VTOL platform that we're integrated with. Wingcopter have also looked at the integration. Hanseatic in Germany as well do a fixed wing petrol drone, which has a 5-hour endurance. So yeah, it's very flexible in its integration. So very user friendly camera, and that's what it's designed for. Is so that it can be used in different applications. It's not a closed box per se.
And we've got a question from Derek. Are you tending to sell to the likes of National Grid or to individual drone operators / companies?
We sell to a wide range in different companies. So we sell to individuals. We sell to larger consortiums as well. But I would say that a lot of those larger consortiums, like Network Rail, for example, they're using individual operators for their application, and the same can be said for National Grid. They do, of course, their own in-house work, but they also have external companies also contracted for some of the power lines. So it's a varied mix of individual data collectors and larger companies that are also purchasing.
Excellent. Well, I think that will do us for the time being. We're just up to our time of the hour, but please send any more questions in to myself at the email, which I'm just going to be putting now in the chat. I'd like to thank Yuri again for joining us and bringing his expertise into this presentation, and as well as James as well for sharing his knowledge and camera details, essentially. So thanks everybody for joining us. My email's there for any questions, and yeah, look forward to talking to you all very shortly. Thanks, guys.
Yep, thank you.